So as we look for the physical properties of the transition elements, they are actually metallic, they have high tensile strength, they are ductile and malleable, that they can be beaten into thin sheets and wires, drawn into wires. They have high conduction power, they have metallic luster too, and there is high enthalpy of ionization, and they are solid mostly except the mercury. So we are going to start with these properties, and more many more properties we will take into consideration when we will study the detailed D block. So the first property we are taking into consideration, as I told you, that I just missed the property, that is they have high melting and boiling point. So now what is the reason that they have high melting and boiling point? The reason behind them is, see, we know that in them there is this d orbital and we have this valence shell. So that means in the bond formation, these d electrons are also going to participate, this s electrons are also going to participate. So as the number of valence electrons which are participating in the interatomic bond formation, the stronger is going to be the bond, and more is going to be the melting point and boiling point, right. So but what we see actually, when we just move from this place to from left to right, we see that the filling of the d orbital take place. But like I am talking about the period. So when we started from here, there was 3d1, 4s2, but at the last there is d10, or you can say this progressive filling of 3d orbital, that is 3d2, 3d3, 3d4, like that. So what happened as they get filled actually, so that means at that time the lesser number of electrons are actually participating in the bond formation, interatomic bond formation. So when there is lesser number of electrons participating, that means the bond will be not so strong. And when the bond will not be so strong, so that means the melting and boiling point will decrease. So as we can say that they generally possess high melting and boiling point, but when we move from left to right, their melting and boiling point is decreasing due to progressive filling of electrons in the d orbital. So that means lesser number of electrons are not going to now going to participate in the interatomic bond formation, and lesser the number of electrons, obviously we know that the melting point is directly proportional to the bonding, the type of bond, the strongness strength of the bond, and which is directly proportional to the valence electrons. So less is the valence electron, less strong will be the bond, and less will be the melting or the boiling point. So that is the reason that when we move, we see a slight increase, but after that we see a decrease in the melting and boiling point. The same reason, due to filling of as the d orbital gets starts filling, so lesser number of unpaired electrons we are left with, right. Like we take an example for zinc, which is present at last. We know that its configuration is argon 18, 3d10, 4s2. So as here we cannot see, we are not able to see any valence electron, that means we are not able to see incomplete electrons, or we can say that the d orbital is completely filled actually. So that means lesser number of electrons are going to participate in the bond formation, that means the bond is not going to be so strong, and if the strength is not too high, so that indicates that the melting and boiling point is low. So this is what is the melting and boiling point.